This video is part 2 of the video series on sequences for Algebra 1. So let's start by reviewing with the problem that we started with in the last video. So we started by looking at dogs, and we were looking at the pattern that is present in this picture. So we looked at each dog, and we saw there was 1 in the first set, 3, 5, and 7, and we noticed that the pattern every time was +2, +2, and +2. So we determined this is an arithmetic sequence because we were adding the same common difference, which in this case is 2. We're adding that every single time. And we found the next 3 terms in the sequence. So what if I ask the question below? How many dogs will be in the 10th picture? Well, that could be kind of challenging because here I only have the first 4. So what I have to do is I have to keep adding 2 a whole bunch of times. And I have to make sure I count it right. And it can get kind of tricky because 10 is not too bad. But what if I asked how many dogs are in the 100th picture? Now it gets really challenging because I would have to add 96 more times, and it gets kind of messy over and over and over and over again. So this can be kind of a tricky situation unless I have something like this. What if I have this formula and I ask what is the 10th term of the sequence? Well, if you remember in the formula, f of n tells me the term number. So if I want to find the 10th term, I would just plug in 10. So that'd be 2 times 10 minus 1, which is 19. So I would have 19 dogs. This is actually the formula for the dogs. So I would have 19 dogs. And if I wanted to do 100, f of 100, so 2 times 100 minus 1 is 199 dogs. So that's a lot of dogs. Now this formula is significantly easier than just adding 2 a whole bunch of times. And so that's what we're going to focus on today. We're going to focus on this type of formula. And this is referred to as an explicit formula. Now what this formula can do is it can tell us the nth term, there's that phrase again, nth term. It just means the first, second, third, fourth, fifth, sixth term of the sequence by substituting a number. Now, what I'm going to show you is this little formula. Now, this formula, if you write nothing else down from this video, write down this formula because this is what we're going to be using to write the explicit formula for an arithmetic sequence. That's why I have this only arithmetic in all caps. This is the formula we're going to be using for this video, and we're going to expand on this as we go throughout the video series. So let's kind of break down the parts. So this first part is the common difference. So this is our common difference. And f of 1 is the first term. Now n here, n is the variable. We're going to leave it as n because we want something in the very end that has an n in it so I could replace it and then find the term in the sequence. So this is the formula you need. So write this down. If you write nothing else down from this video, this is the one you need. So the question becomes, why do we use n? Why are we using n in this instead of x? Because a lot of times we like to use x. Well, there's a couple good reasons. So the first good reason is n is used to represent the natural numbers, okay? And literally coming from natural numbers. Now, natural numbers are the positive counting numbers. So what that means is I'm only going to put in 1, 2, 3, 4. I'm only going to plug in those whole positive counting numbers. Now, you could be wondering, why are we plugging in only positive counting numbers? Great question. Let me counter one. Can we have a term 1.5? If I'm looking at a series of pictures, can I talk about how many dogs are in picture 1.5? Can I talk about how many dogs are in picture 1.8? No, that's kind of silly. The same question to go with that is, can you finish a race in place 2.3? No, your first, second, third, fourth, that's all it is. It's positive counting numbers. So a sequence is the same thing. We're only going to have term 1, term 2, 3, 4, because decimal terms don't make sense in this context. So another big thing you need to write down is that the domain of a sequence is the natural numbers. Now, if you miss the domain and range video, go back and watch it. But domain, if you remember, these are the input values of a function, meaning we only input positive counting numbers. So let me write that down. So we only input positive counting numbers. Because otherwise it wouldn't make sense. We'll get to examples with decimals later, but not in sequences. Sequences are strictly positive counting numbers. We're only going to plug in 1, 2, 3, 4. Otherwise, the whole thing doesn't make sense. So with this formula, just a reminder, the two big things you need are the common difference. So just a refresher, the common difference is the thing or the number we add or subtract to, or let's say add or subtract between terms. Between terms. So we need the common difference, D, and we also need the first term of the sequence, f of 1. And typically they'll give it to us. We'll get to some example in later videos when they don't give it to us, so we'll have to figure that out. So let's talk about dogs still. So we're going to create a table to represent the dogs. We're going to look for the formula and figure out how many are in figure 10. Let's do some counting. So we did this in the first video. So there's 1 dog, 3 dogs, 5 dogs, and 7 dogs. And then if the pattern were to continue, I would have 9 dogs and then 11. So to come up with this, I need two things. I need the common difference, which in this case, my common difference is 2. And I also need the first term. So the first term in this case is 1. All right, so this is a math tip. Whenever you learn a new formula, I would write it down every single time you use it, so that way you'll remember it. So hopefully practice makes permanent. So this is the formula I have. Now the only two things I'm going to replace are the D. I'm going to replace the D, and I'm going to replace f of 1. So let's do that. So f of n equals D is 2, so 2 parentheses n minus 1, plus f of 1. What is the first term? Well, my first term is 1. Now all I have to do is distribute and combine like terms. So I'm going to go ahead and distribute my 2. So f of n equals 2n minus 2 plus 1. So 2n minus 2 plus 1. And then from there, I just combine terms. So minus 2 plus 1 is 2n minus 1. And that's the same formula we came up with earlier. So f of n equals 2n minus 1. And this right here is our explicit formula. Now I want to point something out here. If you notice, our common difference is 2, and 2 shows up right here in front of the n. That's not a coincidence. Now if I want to use this to figure out what's in figure 10, all I have to do is plug in 10. So 2 times 10 minus 1, which is 19. We did this earlier. Let's take a look at two more problems. So here I have two sequences, and I'm going to write the explicit equation for them. So remember, the first two things that we need to find is we need to find the common difference, and we need to find the first term. Now remember, the first term is easy. You just look and say, oh, it's 11. Done. Next, I need to figure out what I am adding or subtracting to get between each term. Now, if you're not adding or subtracting, then this formula will not work. But conveniently, for this one, I am adding 4 each time. So my common difference is 4. So let's write down the formula. So we have f of n equals d times n minus 1 plus f of 1. Again, I would write down the formula every time you use it just so you can get the hang of it. So let's do our substitution. So the only thing we're going to replace is we're going to replace the d, n minus 1, and the first term, which in this case is 11. Next, we do a little simplifying. So we distribute the 4. So I have f of n equals 4n minus 4 plus 11. And then I'm going to combine my terms. So the minus 4, the plus 11. So I get f of n equals 4n plus 7. You could be wondering, how do I know I'm right? That's a wonderful question. What you can do is you can test the formula. So I'm going to plug in 3. So when I plug in 3 to my formula, 4 times 3 plus 7, I should get 19. If I don't get 19, I did something wrong. So let's see, 4 times 3 is 12, plus 7 is 19. Wonderful. So you should be able to pick any random number, plug it in, and it should come out to be a term in your sequence. Let's try another one. So again, I need to find my common difference, what am I adding or subtracting, and my first term. So the first term is super easy here, just 15. Next, let's figure out what we're adding or subtracting. Now I can tell you now just by looking at it, it's subtracting because my numbers are decreasing. So this is going to be minus 3, minus 3, minus 3, minus 3. So there's my common difference, minus 3. So let's write down our formula. F of n equals d times n minus 1 plus f of 1. So let's replace the d and the f of 1. So we have negative 3 times n minus 1 plus my first term, 15. Then we'll go ahead and distribute. So I have f of n equals, we distribute this negative 3, so negative 3n plus 3 plus 15. And then I'll just combine my terms. So f of n equals negative 3n plus 18. Now again, we want to check, we want to make sure that our equation is correct. So I'm going to again, let's test 4. So 4, 1, 2, 3, 4, I should get a value of 6. So let's see if we did that. Negative 3 times 4 plus 18. Oh, getting a little tight here. So let's see what we get. Negative 3 times 4 is negative 12, and negative 12 plus 18 is 6. Lovely. So that is my explicit formula for this sequence. And that's it. That's how you write the explicit formula for an arithmetic sequence. In the next 2 videos, we're going to be looking at graphing sequences and writing sequences when we're short a few terms. Stay tuned.